Hey, I'm super excited because I have now brought the course for my favorite subject, that is fluid mechanics, for the BARC interview preparation. You remember those complex situations when they change suddenly the cross section of the tank, when they change suddenly the pressure on the water level and everything, and they tell you draw the graph without writing any equation, without deriving the final expression. So I will teach you all these things in this course, and just let us see the glimpses of this course. Okay, so here you can see my iPad, I think. So firstly, this is the first chapter, that is that of the tank problems, that is the tank problems. So all those things, those tanks, this cross section, that cross section, varying pressure, and two tanks connected, all those things I have covered. And moreover, you have these notes, I have also provided the notes. Secondly, these are the second chapter, flow problems and pumps. So I have covered the venturi meter, the orifice meter, how to draw the pressure versus velocity curves, those Wood-Patang questions, okay, complex question, problematic questions, how to answer those things I have also mentioned in this course. Obviously I have provided the notes. Finally, I have given you some homeworks also, some homework problems. And let me tell you, I will keep adding content. I will keep adding content in this course which will get you for free, which you will get for free. Now finally, there is a gift for you. And let me tell you that what is the gift. There is a 20% discount for mock interviews, BRC mock interviews. If you enroll for any of the courses, if you enroll for either of heat transfer or fluid mechanics courses, or maybe the courses that I will bring in future, you will get the same code so that you can get 20% discount in my mock interviews. There is no discount currently for my mock interview services. Okay, so that is that. And now let me tell you the pricings. So right now this course is actually big. This course is 2 hour 25 minutes, you can see here, and it will take you actually 899 rupees. But if you are an early bird and if you buy this course within next 24 hours, the course price is, yes, 499. Yes, 499. From 899 it is 499. So I mean, after the next 24 hours have passed, the course price will again rise to 8. Now, if you are buying the heat transfer course and the fluid mechanics course together, the actual price is 899 into 2. But for the next 24 hours, this price will boil down to 499 into 2. But if you are buying this package of fluid mechanics and heat transfer together in the next 24 hours, I have launched a combined package which should actually cost 998, but if you buy it within next 24 hours, this will cost you 899. Okay, this offer is valid only for next 24 hours. Now I have also provided you a sample in this video. Just see this sample. If you like, then only buy, otherwise theek hai, it's okay. Okay, so now let's go to the sample. So now you see again a varying area thing, but now, so this is the same case, that a constant area cross section, okay, is being like पहले ये ऐसा था, constant area cross section glass. I have just tilted it like this, and now I am filling water like this. Okay, so okay, let me totally define the problem first. So if this is your D and this is also your D, okay, so okay, so now you have to compare it with the vertical case, where your, this is D and this is also D. So compare it with the vertical case, right, where the water is flowing again with the same volume flow rate Q. So let us do it, right. So again, if I have to draw this curve H versus T, firstly we know that for the second case the graph will be something like this. So this is for the second case. So let me name the cases also. If this is 2 and this is 1, so this graph is for 2. Okay, So okay, if this is 2, let me draw it with the green color. Okay, this is your 2. Now for the first case, again, can you draw the area here? Pause the video and can you draw the area here? So at any time h, at any time t, the height, if this is the height, okay, this is the height if it is field. Okay, so let me draw it very carefully. Okay, so if this is the height, you see that this is the field portion of water. Okay, this is the field portion of water, and my area is this, my area is this here, area is this here, you see area is this here. So what is happening, if you see very carefully, if this radius, I am just zooming in it, if this radius, if this height h is equals to d by 2, right, then after that this area will decrease, like this. But before this reaches from h equal to d by 2, I mean till h equal to d by 2, okay, if the height is less than h equal to d by 2, then the area is actually increasing. So at first the area was this, where this height is h less than d by 2, and maybe this area here, this height is h equal to d by 2, and this area is this, where here this height h is more than d by 2. So you understood here, if I write mathematically, then for h less than d by 2, area is increasing. For h greater than d by 2, area is decreasing. That means here the slope will decrease and here the area is decreasing. So here the slope will increase. Understood? And in between, what will be the slope? In between, what will be the slope? The slope has to be, so I mean, is it the fact that the slope has to be 0? No. When the slope has to be 0? If the slope is changing its sign, if it is becoming from negative to positive or positive to negative, then it has to change its sign, then it has to be 0. But there is no such restriction. Maybe it is C. Okay, so let me draw the graph, then I will show you. Okay, so maybe I will draw the second case with this color. First it will decrease, then it will increase. Okay, understood now? Okay, again you see that if I have drawn it correctly or not. First, for this part, you see this is the tangent, this is the theta 1, and you see this is here the tangent, this is the theta 2. So this angle is more than this angle, that means slope is decreasing. So this part slope is decreasing. And again for this part, see, first this is the tangent, so this is theta 1. For this point, this is the tangent, so the angle is increasing. This one theta 2 and this one theta 1, right? So this is increasing slope. And you now know this height, that this height will be your d by 2, okay. So you see that how the graph is varying. So here this will be the answer, okay, that firstly the area is increasing, so the slope will decrease, and then the area will decrease, so the slope will increase. So see, if I mean, even if I make some mistake in this video, obviously I will clear that by making any announcement video in the course. Don't worry about that. I will not, see, I am also I mean human, so I can also make mistakes. If I make, then obviously I will admit that and I will clear that out. I will not say that no, I cannot make any mistake. But even if I make mistake, just by applying the fundamentals, you can easily, I mean, catch that, right? So this will be the thing, okay, that here the area is decreasing after d by 2, after d by 2 area is surely decreasing, area is surely decreasing, so the slope has to increase. Okay, so this will be the thing. Now at first what is the area? Area is this much, or area is, you can say that this total is the area, because this will fall onto a total area. So this is a finite area, but here okay, the slope has to be more than this, this slope has to be more than this. Why this slope has to be more than this? Because you cannot start it like this and then you go it like this. Okay, okay, so think about this. Okay, you can have this type of option also. Okay, I am just, so these are your homeworks, thinking homeworks. Okay, you can have this type of graph, you can have this type of graph also. Okay, so you have to think that will this be the point? I mean, why this is not the answer? Can you think that why this is not the answer? If this is the answer, so first of all, how can you get that? So let us see that what is the slope here. See, this is the initial slope theta, and here the area is very less actually. Area is very less. Area is very less. It is, you can say it is almost zero. It is almost zero. So then here actually the slope is first very high. First very high. It has to be very high. It has to be very high. Right? And again it has to be very high. And again here also the slope, the area is very less. The area is very less. So here also the slope has to be very high at the ending point. So at the end points, maybe the slopes will be similar. So this line and this line, they have to be similar. They have to be similar. Okay, but whether, I mean, now this will be d by 2 here. Okay, and if I now plot d by 2 here, okay, so here is my d by 2. Here is my d by 2. So if I ask you that which tank will reach d by 2 first, which tank will reach d by 2 first, can you answer me that? Which tank will reach d by 2 first? So this is also your homework. So maybe this is d by 2, if this height is d by 2, then you have to find out actually, I mean, will they reach the d by 2 height at the same time? Will they reach the d by 2 height at the same time? So these things actually you have to find. So you have to find. Otherwise, let me draw another graph. Okay, so this is an actual BRC question, what I am showing you. You see that here this is the curve maybe for the constant cross sectional area, and here this is your d by 2. This is your d by 2, and it will be exactly tau by 2, the total time by 2. But now here you see that this can be the case. This can be the case. Okay, but and this can also be the d by 2. This can also be the d by 2, and this can be your tau d by 2 for this varying case. For this varying case, this can be the tau d by 2. Now you have to tell me that this tau d by 2 time required to reach the d by 2 height for the vertical case and for the horizontal case, are they same or not? Are they same or not? So that you have to tell me, are they same or not? So if they are same, then this is your answer, then this graph is your answer, and if they are not same, then this graph is your answer. So you have to tell that which is the answer. You have to tell that which is the answer. But for sure this slope will be more than this slope, so this cannot be like this. And if it is not like this, it has to cross it. It has to cross it. So it cannot be like this also. Why it cannot be like this? Because the initial slope and the final slope, they has to be same. And if the initial slope and the final slope, they has to be same, okay, they has to cross the equal slope or the tan theta equals to 45 line. Okay, and again I am just giving you the answer just because from this d by 2, this above portion, okay, if I consider that this h more than d by 2 and h less than d by 2, the area is the area, if this is increasing, it will have maybe 1 0 1 2 3 these values, and now if it is decreasing from 3, it will be 3 2 1 0 because it is symmetric, right? So it is symmetric about this plane. Now if it is symmetric about this plane, so this half and this half, they should take exactly the same amount of time. They should take exactly